Okay, let's review Unit 2 exam. And again, the bell's going to ring, so I'm just going to keep going. Number 1. So I'm going to give you time and velocity data. And so you'll get a data table like this. And guess what you're going to have to do with that? First thing you're going to have to do is graph it. Make sure you label and increment your graph properly. And then just plot the points. And I promise you they'll make a nice straight line like this. The next thing I'm going to ask you to do is to create a mathematical model for this equation. Remember that y equals mx plus b. And so, well, y is going to be your velocity axis, equals the slope. Well, what is slope? It's the rise over the run, delta v over delta t. Your horizontal axis is time, and then plus the velocity when time equals 0, which we call v naught. And remember that delta v over delta t is the definition of average acceleration, and we're just going to call it acceleration right now. And so we have this equation, v equals a times t plus v naught. Notice that's the first kinematic equation. So you'll have to write this equation out like you had to do in the first exam. Remember that your acceleration better have the right number and it better have the right units, meters per second squared, or meters per second every second, right? And in this, what units go with v naught? Whatever that value is, meters per second. So you must include the correct values for the acceleration and initial velocity, and make sure you have the right units for them. Make sure you do know the 4 kinematic equations. V equals v naught plus at. Oh, look, that's this one. Just reverse the order. Delta x equals v plus v naught over 2 times time. Use this one when you don't know or don't need the acceleration. Delta x equals v naught t plus 1/2 a t squared. You use this one when you don't know the final velocity and you don't know it, you don't need it. And then you have v squared equals v naught squared plus 2a delta x. And this is the equation you use when you don't know time. Yes?
Are we going to be given those?
You are allowed to bring an equation list to the exam. You may not use these notes, but you may use these notes to create an equation list that you can use during the test. Only equations. Yes?
Well, we need to know how to, figure them out if it's like kilometers over hours. So we need to know how to do that.
I don't give you anything in kilometers per hour. No. Yeah, those are kind of annoying. All right. Make sure you know how to figure out the slope of or how to calculate instantaneous velocity. Oh, that's the next problem. Let me go to the next problem. Oh, last thing, using this, remember the area underneath here? The area is displacement, right? So if you add up the areas as you go along, that will allow you to create a motion diagram, or a motion diagram. And it probably looks something like this, where the arrows are getting longer and longer. Make sure you have those acceleration arrows along with it. And these has to be quantitative, so you have to, this is x in meters. So make sure that you can make those accurately. Let's go to problem number 2. Oh, that's probably where it is. Yeah, that's where I put it. All right. Problem number 2. I'm going to give you a position versus time graph, but it's going to be a curve, something like this. And maybe I'll say, hey, at this time right here, what is the this is position in meters, time and seconds. At a particular time, you have to figure out what the instantaneous velocity is. That is the slope of the tangent line. So you have to figure out what the tangent line is, and then you have to figure out what the slope of that line is. And of course, all of you will have slightly different answers, but if you're doing it the right way and you're close, you'll get full credit. Remember the slope of a tangent line, delta x over delta t. So you have to pick 2 points on the tangent line, figure out what the delta t is, what the delta x is, divide that delta x over delta t. That is your instantaneous velocity. That is the velocity the object is moving at time t. Okay, so that's instantaneous velocity. Whoops. Then you're going to need to know how to figure out average velocity. Now, if I want to know between, time, maybe we'll call this t initial and this t final. What is the average velocity? Well, and I'm going to finish this, but you may go. You may go. So to figure that out, you draw a line like this, and it's just the slope of the line. It's just delta x over delta t. That's your average velocity. Please be quiet, though, while you're leaving. Shh. Okay. So basically, that's what you need to know is the difference between instantaneous velocity and average velocity if I give you a position versus time graph. Shh. I'm still recording. The number 3. Number 3 is a free fall problem. Okay? And remember that you just use the kinematic equations. You just know that the acceleration is equal to negative 9.8 meters per second squared. And instead of delta x, we're usually dealing with delta y. Remember, if something falls down, delta y is negative. If something goes up, it's positive. Problem number 4 involves 2 accelerations. You're going to get a car like this, and it's going to accelerate forward until it gets here. And then it's going to decelerate until it comes to a stop. So here's the car at a stop. Now what you have to do is you have to divide this problem into 2 sections. So between here and here, the car is accelerating. So you can use the kinematic equations for this time, and then you can use the kinematic equations for this time, the amount of time from here to here. But you can't use the kinematic equations for the whole thing. You have to break it up into 2 problems. So make sure you know and understand how to do that. But do remember this: the final velocity for the first part of the problem is equal to the initial velocity for the second part of the problem, which makes sense, I think. And then finally, number 5. The last problem on the test, number 5, I'm going to give you you have to draw kinematic stacks. So here's position, time, velocity versus time, and acceleration versus time. What if I give you something like this? And then I tell you the initial velocity is here and the initial position is here. So so if this is what's given, you have to draw these 2 graphs. It's pretty easy. You just draw a line down like this. And this says, okay, our acceleration is positive. That means my velocity is changing in a positive way, positive slope, like that. And then here the acceleration is 0, so my velocity is going to stay constant. And then if I go up like this, well, the velocity is 0, so it curves up like this. Just a second, almost done. And then the velocity is constant, which means this is a straight line. So you'll have to take one of these and draw the other 2. might give you position versus time, you have to get velocity and acceleration. Or velocity versus time, you get position or acceleration. Well, actually, on the test, I do that for all of them. So anyway, that's what's on the test. Good luck. That is all.